So these three problems are a review from the previous assignment. If two fractions have like denominators, how do you add them or subtract them? Just combine like terms in the numerator and keep the denominator as it is. So the first one, the x and the 3x make 4x. The 2 and the negative 4 make negative 2 over 6. Am I done? No, because I can pull a 2 out of the top. So 2 times 2x minus 2. And that 2 turns the 6 into a 3. Oh, minus 1, sorry. So it's 2x minus 1 over 3. Okay? All right, in the next one. So don't forget that this is a subtraction problem. 5x minus x is 4x. And 4 minus negative 10 is 6. So plus 6 over 2x plus 3. Does it go further than this? I can take a 2 out of the top, and I get 2x plus 3. Oh, imagine that. We call those, I had a math teacher that called those problems hokey. If something that looks really difficult simplifies down to something really simple, he called it hokey. So that problem was hokey. Okay, so over here, 3x and negative 1 make 2x. Negative 1 and negative 3 make negative 4 over. Does the bottom factor? Are there two numbers that multiply to be negative 4 and add to be negative 3? Negative 4 and 1. So this would be x minus 4 and x minus 1. Does anything cancel? I can take a 2 out of the top. 2 times x minus 2, but that doesn't match any of the factors in the denominator. Oh, that's twice now. Oh, the bottom. Forget I said anything. Moving on. Okay. So today, we are dealing with unlike denominators. Now, one way to solve unlike denominators, and this will always work, although I don't really recommend it, is times each fraction by the denominator of the other fraction. So, I can times this one by 10 over 10, and this one by 6 over 6, and I get 20 plus 30 is 50 over 60, which simplifies down to 5/6. Okay? Did I need to actually multiply by 10 and by 6? Is there a common denominator lower than 60 that 6 and 10 both go into? 30. And the way you can find that, if you factor the bottom, 2 times 3 and 2 times 5, the denominator needs everything that's in both fractions, but it doesn't need duplicates unless a particular fraction has a duplicate. So how many 2's do I need in my common denominator to cover everything? Just 1. So my common denominator would be 2 times, we need a 3 and a 5. Now, that happens to be 30. So why don't I need that other 2? They all, the most that either one has is a single 2. So the most the common denominator needs is a single 2. So if I were to solve it that way, I would end up multiplying this by what it's missing, a 5, and this one is missing a 3, and I would get 10 plus 15 is 25 over the common denominator 30, which happens to be 5 over 6. So you can just multiply everything on one side and everything on the other, but that will leave more simplification at the end, and when things get more difficult, you won't want to do it that way. So let's try another one. Should I multiply the left by 30 and the right by 24? Will it work? Yeah, it'll work, but I don't want to. So this is 2 times 2 times 2 times 3, 8 times 3. And the other one is 6 times 5, which is 2 times 3 times 5. So what would my common denominator be? 3 2's. 1, 3, and 1, 5. So what does the one on the left need? Just a 5. So that would be 35. What does this need? 2 more 2s, so multiply it by 4. It's already got a 3. It's already got 1, 2, and a 5. So instead of multiplying one side by 30 and the other side by 24, we're going to multiply the left by 5 and the right by 4. And that will keep our numbers a lot smaller. So minus 24 is 11 over 8 times 3 is 24 times 5 is 120. If I did it the other way, I would have ended up with 7 times 30. I would have done 210, and then 6 times 24. So 210 minus 144 is 66, and that would have been over divided by 24 times 30, which is some big number, and it's going to simplify. Oh, apparently I don't know how to run my calculator, so now I'm going to mess it up. So it was 144 divided by 24 times 30. Oh, somewhere I messed up. Oh, it was 66 divided by is 720. 24 times 30, 3, 7, yeah. Which is 11 over 120. So it's going to work either way, but you kind of want to try to do it the smart way. Okay, look at this one. Oh, hey. So now we're introducing polynomial or rational expressions. What is the common denominator going to be? It's going to be 3 times x plus 1. Now, you can combine that if you want, but it's a lot less useful for us. So we're going to leave the common denominator as 3 times x plus 1. That way we can find wholes, we can cancel. If you put it together, then you're going to have to factor it again in the end. So we like to leave our denominators like this. So what does the left side need? It needs a 3. What does the right side need? An x plus 1. So distribute that. 3x plus 9. Distribute this. Plus 5x plus 5. So on top, those combine to be 8x plus 14 over 3 times x plus 1. Can I pull anything out of the top? A 2, is that 2 going to cancel? No, so I'm not going to bother. I'm not going to mess with it. Well, and if I pull it out, I'm left with 4x plus 7, and that also doesn't cancel, so. You can put it back together, but a denominator is much more useful factored than it is multiplied through. It's all the same, really, but this tells us a lot more about the graph and the wholes and all of that, so we tend to leave it in that form. Okay, so let's try x plus 1 over 5x y squared plus 7 over 10x squared. What is the common denominator going to be? Well, this is 2 times 5. How many 2's does my common denominator need? Just a 2 times 1, 5 times x squared times y squared. Does everybody get that? So what does the left side need? It's missing an x and a 2. So I'm going to times this by 2x. What does the right side need? Y squared. So that would be 2x squared plus 2x plus 7y squared. Can I factor the numerator? I could try, but I'm going to end up, if I draw the box, well, no number comes out and no variable comes out. If I draw the box, 2x squared times 7y squared is 14x squared y squared. Are there factors of x squared and y squared that add to be x? No, it's not going to work. So if you tried to factor it, it's not going to work. We usually do just change this to a 10, but that's as far as that one goes. It won't go any further. Okay? So what about 3 over x minus 5 minus 4x? Ooh, that's going to make it bad. We don't want to. Oh, whatever. 4x plus 3 over 2x minus 1. As written, do the two denominators have anything in common? Is there any overlap from one denominator to the other? Well, we have to treat them as a single group. So x minus 5 is a factor, and 2x minus 1 is a factor, and they're different factors. So the common denominator is going to be one version of each, x minus 5 and 2x minus 1. So what does the left side need? It needs a 2x minus 1, and the right side, an x minus 5. So the left side gives me 6x minus 3. And the right side, don't forget the negative. Right side is going to be negative 4x squared. And then this gives me negative 20x. And that gives me 3x, which is negative 17x, but it's a subtraction problem, so it's actually plus 17x, and then the last two give me negative 15, which is actually positive 15. So, negative 4x squared, 6 and 17 make 23x, negative 3 and 15 make plus 12. I would probably want to pull out a negative 1, but let's just check. If I multiply negative 4 and 12, I get negative 48. Are there factors of negative 48 that add to be 23? So 1 and 48 doesn't work. 2 and 24 doesn't work. 3 and 16 doesn't work. 4 and 12 doesn't work. It's not going to factor. So that over x minus 5 times 2x minus 1. Does that make sense? Let's just look at a couple on your assignment. If you look at number 2, what's the common denominator going to be? 12 xy to the third. So what does the left side need? It's missing a 4x. And what is the right side missing? 3y squared, because it already has 1. You could put y to the 4th, but that's putting in more than is necessary. Is 3 enough to cover that? Yes. Is it enough to cover this? Yes. So 3 is the minimum you need. If you happen to put an extra 1 in, then you'll put an extra y here and an extra y here, and that y will factor out at the end, and then you'll cancel it. So you want to put in the minimum possible to cover everything that you see. So really, you just look at the y's. Whichever group has the most y's, that's the one you want to write down. Okay. What about number 6? Well, what about 4? What do you do when one of them is over 1? just multiply this side by that denominator. So this needs everything, 12a squared b. And then you'll simplify. Okay, number 6. Sorry, did I do that too fast? So this is over 1. So the common denominator is 12a squared b. The left side already has everything it needs. The right side needs everything. So you multiply that by 12a squared b. And then simplify. Okay, look at number 6. What's the common denominator going to be? Well, do either of the denominators factor? No. So it needs one of these and one of those. So 5r plus 6 and r minus 3. So the left side needs an r minus 3, and the right side needs a 5r plus 6. Okay? You got the hang of that? It's only Tuesday, guys. Okay. Good luck.